by this point. So it certainly seems not an unreasonable experiment to try and conduct. Whether James Webb would be a suitable mission for trying to detect that, I think the chance of you writing a proposal to search for technosignatures with James Webb and being accepted is infinitesimal. It's just the climate of the field is not lukewarm enough in any sense to consider a proposal to search. It's just too expensive a mission. It's a $10 billion mission. Every second of telescope time is very precious to them. So unfortunately, they're not going to use the time to do that kind of science. So the best way to detect a technosignature would be in surveys. So James Webb is not a survey telescope. It will look at individual stars or individual fields, whereas Kepler surveyed 200,000 stars simultaneously. TESS is a survey monitoring a similar number of stars across the whole sky. LSST in the future will monitor something like 10 billion stars, and Gaia similarly has monitored billions of stars. So if you can think of a way that a civilization might betray its presence in one of those types of surveys, then I think you have not only a much larger sample of stars to interrogate your hypothesis, but you're not going to come up against this boundary that nobody's going to give you any time on the telescope to do it, because the data's already been taken, it's already observed, it's in the archive, and you can just go through and look for it. So I think that's going to be where technosignatures is focused on for the next few years. Maybe if we start seeing really plausible candidates, we might start getting time with James Webb to pursue them. But right now I can't see it happening to do a blind search for technosignatures. You're not going to get a telescope time to do that.
Which, it has to be said that we are a technosignature producing civilization, so clearly it can happen, just maybe not very often. So by looking at surveys, it'll be things like, like how Tabby Star was discovered just serendipitously in a survey. Particularly the LSST is interesting on that, because that's looking at what is it, every day and a half or something like that, it takes a whole sky survey. I guess one of the most unambiguous technosignatures would be lasers. If you saw laser communications or something like that. What other unambiguous ones are there? You have lasers, you have radio signals, but those don't really seem to be all that unambiguous. What else is there?
Yeah, I certainly think these alien megastructures, if they had specific imprints, they could be essentially impossible to explain naturally. You can imagine, like I said, like the Lucarno giant triangle. Triangles just do not form in nature. Like, you just don't find them in the sky. There are no triangular planets, stars, or galaxies out there. So if you see something like that, it really does imply something artificial. In terms of the transit method, which is something I'm probably most familiar with, you can even use the lasers to do this. We argued in a paper a couple of years back, much cheaper. We think that the moment of transit is kind of a special time. It's a time we know when we see a planet transit, that if there was a civilization on that planet, they would be able to predict when we could see them transit. It would actually be a fairly straightforward calculation. And likewise, it's straightforward for us to calculate when the inhabitants of, say, Proxima Centauri b could see us transit in front of our star. Actually, Proxima Centauri b is not at the right inclination to see us transit, but in principle, we could do this for any star. We could calculate when it would see us transit. So that moment is kind of special because it's a time that everybody in the universe can agree upon as an unambiguous special event that's happening in the system. And it's also an interesting time to observe the system because you know that this is your opportunity to smell the atmosphere of the planet, for example, using transit spectroscopy. So we've been arguing that this moment of transit is what you'd call a Schelling point, which is an idea from game theory. It's an idea of if you can't communicate with the other players of the game, how do you agree upon a single location to meet or a single medium of communication? And a Schelling point in possible ETI communication, I think, would represent the transit, the instant of transit. Now, that might mean that they are pulsing some laser at us at that moment in time, a very specific pulsing or frequency that we are not yet looked for, or it can mean there's radio communication at that time. But I think exploiting the astronomical Schelling points that are presented to us is helping us to deal with this haystack problem. There are just so many infinite number of radio channels to search through and so many infinite number of possible moments in time to look at that we need to somehow narrow down when to look for these techno-signatures as a way of improving our odds of success. It doesn't mean you should ignore the other times, but it means that you might want to add a little bit more priority to the observations at those special times.
So one of the other things that Arnold noted in his paper was a louver. You know, you could have something really unnatural, even worse than a triangle, really. This seems like a cheap way to announce to the galaxy that you exist. Cheaper than building an omnidirectional radio beacon blasting out, the hydrogen line or something like that. But if a civilization did that, they built something that says, we're here. Could you actually communicate visually? Could you send data to another civilization across, space by using that visual method, the louvers and things like that? Or would that just never be decipherable?
You could. It would be a very low information transfer rate, of course, limited by the speed at which you could move these giant structures around. I'm not convinced personally that this is necessarily an economical way for a civilization to go around announcing itself. To come back to this, this paper that we wrote a couple of years ago, we think actually the lasers are a much cheaper way. So just during that moment of transit, you fire a laser at whatever star you think might be observing you, and you could either distort your transit to look very peculiar, invert it, sculpt it, do etch-a-sketch in the middle, and do like the Manhattan silhouette or whatever you want in the center of that transit. And probably the most artificial thing you can do to your transit is to make it a pure box, which you're easily able to do with about a 10 megawatt laser. That sounds like a lot of power, but it's absolutely nothing compared to the amount of energy you need to build a giant megastructure around the sun. So we argued that this is an appealing method because you can make extremely artificial looking transits, and then if you more carefully monitor the laser beam, you could pulse it, you could modulate the frequency and do very high data transmission rates down the laser beam itself. So I think it would be more appealing to use optical laser emission or something rather than building a giant structure, because you really can only announce yourself with that. You can't actually carry information, or at least significant amounts of information.
Now that of course segues into a paper you once wrote. You could also use lasers to cloak your planet from others. How would you do that?
So this is kind of the extreme end of the scenario, but I mean, a planet transiting a star is essentially a dimming of the star, right? That's what an observer would see. They see the planet block out some of the starlight for a short amount of time. So you could cloak that transit signature, if you so chose to, just by creating an equal and opposite brightness increase at that moment in time. And because you know which observer you're trying to mask yourself from, then you could just use a laser. So the idea of using a laser is that it's very narrow band, right? You can just direct it at a single target, and thus it requires far less energy than trying to do it across the whole sky. You could equally do this across the whole sky if you had that requirement, but it would cost a gigantic amount of energy to do that. But it's fairly straightforward. You can do it with our current technology. You can do it. You could basically have these sweeping super spectrum lasers, which can more or less match the exact spectrum of the sun, and just create an equal and opposite brightness and direct it towards the nearest habitable planet at the very rare moments when we transit in front of the sun as viewed from their perspective. And it would cost you almost no energy to remove your transit signature. And you can even go further than that. We talk about how that would be kind of peculiar because you'd still detect the planet in other methods. Maybe, for example, the radio velocity method, you'd know there was a planet there, but it doesn't seem to transit. And maybe you'd even think that it should transit for some reason. Then what you could do is keep the planetary transit there, but just mask the biosignatures with one of these lasers. So you could just make the atmosphere look sterile and dead if you wanted to as well, just like a giant hydrogen envelope or whatever you wanted to. So it's there's certainly games you can play. I guess the reason why we wrote that paper was to point out that this is just a toy example, if you like, of how we may not be as smart as we think we are. We think we can detect an alien civilization across the stars, but if they want to hide from us, they probably can. And maybe this is not the method they choose to hide from us, but pretty much any method we're using to detect planets or smell their atmospheres, it's not unreasonable to think there are certainly means of evading our detection. And thus that kind of problem when you think about how to statistically interpret the null results of such surveys.
It's an interesting idea, because if we detected a techno signature, really, really powerful one that said this is an extremely advanced alien civilization that's 20 light years away, we might we might want to think about cloaking Earth if we were in their line of sight as far as transits go. And on that, we are out of time. Professor, thanks for joining us today, and I hope you'll come back.
Yeah, thank you for having me.
Historically, first contact between peoples on Earth rarely goes well. This may also be the case for very different species in the galaxy, entirely alien to each other. There would be few commonalities as far as communications go, at least initially, and it could turn out that visibility in the Milky Way is inherently dangerous. Distance mitigates this somewhat. Most of the galaxy can't know about our technological civilization, which has been visible only about a century. And there seems little point in traveling great distances just to go into conflict with a civilization. That requires a lot of energy. But what if someone were discovered very close